Hey, welcome to our second day with logarithmic equations. Today, we're going to see logs on both sides of the equation and see how that changes our game plan. In this first example, the good news is we've just got a single log on each side, so that's good. And what we're really going to focus on is, what do I do with this coefficient? Is that a big deal? How do I handle that? And then in our next example, we're seeing, okay, now we've got multiple logs on the left side, so let's condense them first and then see what we do next. All right, so here's our game plan for solving equations with logs on both sides. And first of all, we want to rewrite or express the equation in the form, let's say, log base b of m equals log base b of n. In other words, what they're saying is we've got to condense wherever possible. If we've got 2 logs on the left, we got to condense them into 1. If we've got 3 logs on the right, we got to condense all 3 down into 1. The key is we want to get it down to a single log on each side whose coefficient is 1. A lot of times that's not emphasized or appreciated as being a big deal, but we've got to make sure we've got a single log with a coefficient of 1 on both sides. Now, once we do that, once we get into that single log on the left, single log on the right, we can rewrite it without logs and just say, well, in that case, m has to equal n. We saw something really similar with exponential equations not too long ago, and we said if we have b to the m power, and that's equal to b to the n power, well, the only way those expressions could be equal is if m was actually equal to n, and then you solve. And the same thing holds water here in this case. All right. So then again, solve for your variable and then check your proposed solutions. And we just have to make sure that we're not taking the log of a negative number or the log of 0 once we plug those solutions back in. So here's our first example. We've got single logs on both sides. That's the good news. Now, what do we do with the 2? So remember, our third log property says this 2 can become the exponent, right? So I'm going to say the log of x squared equals the log of 16. So we've accomplished step 1 where we've written each side as a single log and the coefficients are 1. So what you can effectively do is say, okay, this inner function must equal this inner function here. So we could say x squared has to equal 16. If I take the square root of both sides, I'm going to get plus or minus 4. So I'll first plug in positive 4. And that one checks out okay because we're positive right here. But when I plug in the, whoopsie daisy, if I plug in the negative 4, now you're taking the log of a negative number, and that's big time bad news. So because of that negative right there, we're going to reject negative 4, and only positive 4 is my actual solution. Cruising right along. Good news on the left side, we do have a single log on the left side, but now we've got a condense on the right-hand side here. Now in this particular case, I'm seeing this plus sign, so I'm going to multiply this quantity by this number right here. So we're going to have the log of 3x plus 9. Make sure you distribute that 3 all the way through. At this stage of the game, we know this inner function must equal this inner function. So we could say 2x minus 1 must equal 3x plus 9. It's a nice linear equation at this point. I could subtract 2x from both sides and then simultaneously subtract 9 from both sides. We'll get negative 10 equals x. And now you're thinking, I wonder if that negative 10 is okay. So let's attempt to plug it back in. So we'll do log of 2 times negative 10 minus 1 equals the log of negative 10 plus 3. And I think our suspicions are going to be confirmed. So what you're seeing here, this comes out to be negative 21. This turns out to be negative 7. So that is cause for rejection right there. We're going to reject the only proposed solution we had, and we're going to say empty set, or something. Either one of those notations indicates empty set. There's no legitimate solution, unfortunately. All right, let's test our luck on this one. So right away, we're seeing multiple logs on the left-hand side. We're thinking condense, and because of that minus sign, we're going to take this quantity and divide it by this quantity right here. So we've got the natural log of x plus 2 divided by 4x plus 3 equals the natural log of 1 over x. Okay, at this stage of the game, we know that this inner function has to equal this inner function. We'll equate those, basically cancel out those logs. So x plus 2 over 4x plus 3 is equal to 1 over x. I think I'd like to cross multiply here just be careful as you cross multiply. We got to be sure to distribute. So we get x squared plus 2x equals 4x plus 3. So in this case, we're solving a quadratic equation as opposed to that previous example. We were just solving a linear. I'm going to try to move all the terms to one side, set everything equal to 0. Oops, that's going to be minus 3. Got to be very careful with my signs here. Fingers crossed that it's factorable. Let's see what we got cooking here. So I'm thinking x minus 3, x plus 1 gets the job done. So once I tee this up, I get x equals positive 3, x equals negative 1. And let's see if either of these or maybe both of these check. So substituting a 3, let's see, I'm going to just kind of do this one mentally. Substituting a 3 gives me a 5. That's okay. Substituting a 3 gives me a 15. That's okay. And I get a 1/3 here. 1/3 is okay. As long as it's positive, we're okay. So definitely the 3 checks. Now let's try the same thing with negative 1. Substituting a negative 1 gives me a positive 1 there. We're okay. However, I get substituting a negative 1 actually makes negative 1 here and makes negative 1 there. So that's bad. We're going to reject the negative 1, and only the positive 3 is my actual solution. So hope you feel pretty good. Let's dive in and go try some examples.